Good morning, good afternoon, or good evening, depending on where you are. And thank you for joining this learning experience brought to you by ngrok. My name is Cody, and welcome back to Techstrong Learning. Before we dive into today's conversation, I have just a couple of notes to review with you. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we'll be sure to send you an email with a link to access the recording on demand, and we'll send that out to you shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions, we've got some time set aside at the end to dive into a Q&A period. So do send those into that Q&A tab on the right side of your screen as well. Now, on the left side of your screen, you'll find a list of resources that have been added for you. So feel free to grab those while you're here with us. And we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in chats, send in questions, and to fill out our survey that is attached to the handouts, but we'll also post that in the chat toward the end of our session. So without further ado, let's dive right in. Our topic today is Ship Safer Apps Faster with ngrok and Linkerd. I'm joined today by Shub Arga, Solutions Architect at ngrok, and I'm also joined today by Flynn, a Tech Evangelist at Buoyant. So Shub and Flynn, thank you both so much for joining us here on Techstrong Learning. Shub, do you want to dive us right into things?
Yes, thank you for that great introduction. Flynn and I have done this presentation before on shipping safer apps faster with ngrok and Linkerd. ngrok and Linkerd have been partners in our mission to make sure everyone is shipping resilient apps as quickly as possible so we can increase the pace of innovation online. Flynn, do you want to say anything to introduce yourself before I dive in?
I think that about covers what we're doing here. I am a tech evangelist with Linkerd right now. I don't remember exactly how long we've been dealing with each other, Shub, a year or so. But I think that kind of means that we don't really have a lot of excuses if we get it wrong this time.
Yeah.
So it'll be fun to see. Everybody pray to the demo gods and we'll find out what happens.
There you go. Well, with that, I'll dive right in. The first thing I want to talk about is when I am building an application and I want to let other people use my application, or I've got a service within Kubernetes and there are other folks outside saying, oh, let me get access to your application. That's usually the first problem a dev has. And we call that thing ingress, right? The ability to say, hey, how can I let these people get access to the services that I've created?
You will literally hear people talk about the ingress problem, and this is it.
Yeah, and in a lot of places, this is the only problem that a dev has to work through, right? How do I get these people who really want to use the services in this application that I've built for myself, give them a door to get access to all these places? And that's where ngrok comes in. ngrok is a globally distributed, environment-agnostic, unified ingress platform. That also means an API gateway on top of that. With that, what does that mean? What does unified ingress platform mean? We know ingress means getting access to these services and applications that I've built, but what does it mean for it to be unified? For it to be unified means that regardless of where that application is, whatever that application is written in, or however it is being served, ngrok can give you access to that application itself. So, Flynn,
I think the only real requirement y'all have is that your application has to be able to talk to the ngrok platform. You don't even need a path in. Your application just needs a path out, right?
Exactly. So in a lot of cases,
which is pretty cool.
Yeah, in a lot of cases, you're having to set up a load balancer or like make tweaks to your firewall to let incoming traffic get access. ngrok works a little bit differently. We talk out to the ngrok edge, where we take care of authentication and acceleration, that load balancing piece, IP policies. We accelerated with our global points of presence. And of course, you want to make sure that you have oversight over all of your services, right? So we give you a place to do that as well. And that's what it means to be unified, right? So regardless of the place it's being hosted in, if it's AWS or GCP, if it's using Kubernetes as a containerization service, orchestration service, or if it's just a IoT device or a Go app, you can use ngrok to get access to it in a easy, efficient, automated fashion. Now, today we're going to be focused on the Kubernetes world, right? We're talking about services that are orchestrated using Kubernetes. These are containerized services. And ngrok provides two ways for you to go about getting access and ingress into those services. The first is through our ingress controller, and the second is through our gateway API operator. If you check out the handouts, you will be able to see a deep dive into both, a comparison of both. Gateway API is pretty new. Glenn, you have anything to say about Gateway API before I jump into Ingress Controller?
It's the thing that I always find interesting about Gateway API is that it's simultaneously pretty new and it's been around for a few years already.
Yeah.
But yeah, it's so okay. Quick caveat. I spend a fair amount of time talking with the Gateway API project leads because I am one of the co-leads of the Gamma initiative that's using Gateway API for service mesh stuff. And yeah, Gateway API has some really cool stuff. The huge win of it is, well, so if you're working with Kubernetes right now and you learn how a deployment works, then you just know how a deployment works. You don't have to go and relearn how does it work on GKE, how does it work on AWS, whatever. But for the most part, if you learn how an ingress resource works, then you are likely going to have to go and relearn some of that if you switch to a different ingress controller. The real promise of Gateway API is bringing that sort of reusability and transferability of knowledge to the ingress world. That's really cool. It is a very difficult problem. And there are still a lot of things that Gateway API is not yet capable of doing, but we're working on that. So, stay tuned.
Yeah.
I think that's the simple way to put it. I think for this demo, we're still sticking with ingress, though, for ngrok, right?
Yeah, we're sticking with the ngrok ingress controller. It's funny that you mentioned how new, it still has in nascent days, right? Still, people are still learning how to use the gateway operator. I've had conversations with folks whose their company initiatives are to move from ingress to gateway spec.
There are some really good reasons for that.
Yeah.
The ingress resource, as opposed to ingress as a problem or ingress as a concept, the Kubernetes ingress resource has a lot of very real problems that people are trying to get away from. And that was one of the big reasons that Gateway API even came about in the first place.
Yeah, and some of those problems is why the ngrok ingress controller exists, right?
Yep.
We try to simplify it as much as possible. So I'm going to drive right into the ngrok ingress controller. As an ingress controller, ngrok's job is to handle north-south traffic. And that means traffic from the outside world, folks like me who want to access a service that's hosted or application that's hosted within a Kubernetes cluster. And we need to be able to do that in a secure fashion so that only the folks who need access get access, and we don't just open it up to the whole World Wide Web, right? Additionally, we want to make it easy to configure, right? So ngrok gives you a way to easily configure it from a simple manifest. You'll deploy and you'll see us demo that as we move on. But it should be an effortless configuration. A lot of folks, in a lot of cases, this is one of the issues that Flynn was talking about. In a lot of cases, when you're talking about the ingress resource, you have a lot of other things you also have to set up in addition to ingress, right? So you have to think about setting up load balancers, and then figuring out how your IPs work with your NAT, and then figuring out how your VPC is even like set up in a way to handle that ingress, right?
NAT is the root of all evil.
Yeah, depends on how you got it set up. And like if you're using one of like the managed cloud resources, it gets even harder, right? So you have to learn a whole new thing every time you want to set up ingress, which should not be the case. So ngrok exists to make that effortless and make it easy to configure. Additionally, in a lot of cases with ingress, you want to have that load balancing piece without having the hassle of setting up that load balancing piece, right? If you've got a application and you're getting folks who are logging onto that application from Europe as well as the United States as well as in South America, you want to make sure that each of them have the same great experience and one doesn't lag behind the other, right? Delivering that best experience for all of your customers across the world is very important. And that's where that load balancer piece is important to set up. But in a lot of cases, it's very hard to, because you'll have to set up these points of presence across the world just to be able to get to that place. With ngrok, we do that for you. So regardless of where you've got your application deployed, ngrok will make sure that all of your customers, and regardless of where they are, have the best experience as well. Lastly, with that effortless configuration, we know there's a lot of things that need to happen to traffic before it gets delivered to the service itself, right? So we want to make that easy as possible as well, and we want to make it self-service. So for those things like encrypting that traffic, so using things like TLS termination or mutual TLS, doing authentication on that traffic, which we'll get into a little bit today, blocking those unauthorized requests, redirecting them, playing around with traffic, having observability of that traffic. You want to be able to do all of that before your traffic reaches your service. So that is also very important. And we want to our goal was to make sure with our ingress controller that developers have the best experience to set up that ingress resource, because it is, again, one of the things that's one of the problems that they have first when they're setting up an application or service. Cool. So with that, I'm going to hand it over to Flynn here to talk about Buoyant and Linkerd.
And now we get our first fun thing where we get to find out if everything is going to work as I try switching the screen share.
There you go.
Did it work? Hey, look at that. Yeah, it's always nice when things, do the right thing. So yeah, Linkerd. This is kind of our shock and awe slide about Linkerd, where we talk about it being ultra light and ultra fast and how many Slack channel members we have and all this kind of stuff. And it's probably out of date. I think we're up to 10,000 by now. But this is what we really want you to take away from the shock and awe slide, is that the purpose of Linkerd is to arrange it so that everybody working on applications in the cloud native space has all of the tools that they need to create secure, reliable, observable cloud native applications. Kind of in that order. If it's not secure, it doesn't really matter how reliable and observable it is, but you got to have reliability, you got to have observability as well. Linkerd is a service mesh, which is to say it is an infrastructure layer that provides security, reliability, and observability features at the platform level underneath your application, uniform across the entire application, without requiring you to change anything in your application. A bunch of the stuff Shub was talking about just a second ago about traffic before it hits your cluster. Before it hits your cluster is the relevant part there. And then once it hits the cluster and it's in, then Linkerd needs to be worrying about that, because one of the interesting things about ingress controllers as a set of tools is that ingress controllers only get to operate right at the edge of the cluster, at the edge of the call graph. Service meshes get to see everything happening in between the different pieces of your application. The way this works on Linkerd's part, but also most of the meshes out there, deal with this by sticking a user space proxy next to each of your application pods and then reconfiguring things so that the proxy gets to take over all of the network traffic so that it gets to mediate and measure all of the communications between pods in your application. This particular thing is showing only Kubernetes pods, but as of recent Linkerds, you can actually use Linkerd as well and to extend the mesh outward onto workloads running on Linux boxes that are not part of the cluster and still get the same benefits there, which is also kind of fun. There's also a chunk of Linkerd that is managing all of those proxies. We're not really going to talk about that a lot today, but it's kind of relevant to know that it's there. So I think that this is let's get on with the demo slide.
POW slide.
Well, yeah, that too. So what we're going to do here is we are going to set up a Kubernetes cluster. We're actually going to do this all the way from the beginning. I do not have a cluster running right now. We're going to fire it up. We're going to configure it. We're going to do the whole thing live, and we're going to hope that it works. But the way we're going to do this is we're going to have the Kubernetes cluster running an application. We will install Linkerd into the cluster. Then we will install the ngrok ingress controller, and we're going to mesh the ngrok ingress controller so that it is working with Linkerd. Then we'll install the application, and then we're going to put in an ingress resource that will connect the ngrok ingress controller. Please note, an ingress resource will connect the ngrok ingress controller, which is the code part, to the ngrok. What do you guys call this? The ngrok network, ngrok application?
I call it the ngrok network plane.
Okay.
Service.
And that will arrange for us to be able to take traffic from outside in the wide world and route it all the way back to this cluster, which will be running on my Macintosh with no inbound access permitted to it whatsoever, because my firewalls are good and I don't want to mess with them. So we'll see how that goes. We are not going to show you the part where I go through and sign up for accounts everywhere, because that part's really boring. So we're not going to do it. But it is there, just something to bear in mind. Our application is the world famous Faces demo. I'm sure it's world famous for some value of the world, which shows you a bunch of faces on colored backgrounds and this little grid of cells. It works. We start with a cluster and a web browser. The web browser is going to load the Faces GUI, which is a single page web app. Inside the cluster is a workload called Face. So for each cell, the browser will go and ask the Face workload to get the contents. The Face workload will talk to the Smiley and color workloads. When things are going well, the Smiley workload will return a grinning smiley face. The color workload will return this blue. The Face workload will composite them together and then hand them back to the web browser, and you get this pretty little grid of grinning faces on blue backgrounds. That's the way it's supposed to work. Under the hood, we will be using ngrok to provide ingress, the concept, from the web browser into the Face workload in the first place. And we will be using Linkerd all over the place to secure all of the communications within the cluster, and also to provide reliability and observability and things like that. And we will show off a couple of the things that can happen in those worlds. You pretty much should always see this grinning face on a blue background when we start. There are some other things that you might see. Honestly, for this demo, you should really like that one with the grinning face and a gray background. You'll probably see that one quite a bit. These other ones hopefully won't show up. If they do, that tells us that the demo gods are really, really not kind today. All right. We talked about this a little bit. That's just kind of showing a quick sample of what the ingress resource looks like itself. We will look in greater detail at that during the demo. So let's go and take a look at the demo. Okay. I don't think, well, wait, maybe I do see some questions that we should get to beforehand.
You think we should answer them before?
Say again?
You think we should start with them?
I think they're both questions that we can come back to after. So okay. If we don't get to those, then Cody, I'm a rely on you to bug us about them. All right. So we're going to start by creating our cluster here. And well, okay, I kind of lied. I already created the cluster. There's a cluster, it's running, it's empty. We're going to start by installing Linkerd into the cluster. For the record, I created the cluster by running k3d cluster create. It was a very challenging, difficult operation. Now, I am going to be using Buoyant Enterprise for Linkerd for this. And if you are going to use this yourself, you will have to go sign up for a free account with Buoyant. I promise you, we won't sell your email to anybody. It'll be okay. When you do that, it will walk you through setting these 3 environment variables with your client ID, your client secret, and your Buoyant license, kind of like the same way it happens with Auth0 or any of the other platforms like that. I have already done this, so these are already set, so I can go ahead and get in with installing this. I'm going to start by installing the Linkerd CLI, which is just a thing you download with curl. And then I will use the Linkerd CLI to install the Linkerd CRDs and apply them to the cluster. The Linkerd CLI never directly modifies your cluster. It just outputs a bunch of YAML that you then apply on your own. This next one is installing Linkerd itself now that I have the CRDs in place. If I try to do this without installing the CRDs, it will yell at me and not go on. The last bit we're going to do here is install Linkerd Viz, which is Linkerd's observability dashboard. And we're cheating a little bit here. I just installed the Linkerd control plane. I did not sit back and wait for it to come up because I knew I was going to be running Linkerd Viz install, and that will wait for the control plane to be working as its first step, so I don't need to do it myself. This is one of those steps of the demo that always takes just long enough that I start to worry if the demo is really working. There we go. Okay. Last thing, we're going to use the Linkerd check command, which goes and checks to make sure that everything is happy. And at the end of this, we should see a green check mark, which means that everything is happy. So this is the first opportunity for the demo to blow up in our faces.
Let's hope it doesn't.
Yeah, this part usually works pretty well.
Yeah.
We've actually watched this exact demo run many times successfully over the past few days. So it really should not blow up in our faces, but you know, we're doing this live, so who knows?
Let's just hope we
There
don't
we go.
your laptop again. There you go.
Yep. Okay, so now we have Linkerd running. You can see this bit here that says status check results are and a green check mark, which is great. So the next thing we're going to do is install the ngrok ingress controller into the cluster. And in much the same way, when you do this, you have to go to ngrok and you have to create yourself an account there so that you can access, what did you call it? The ngrok network plane?
The ngrok dashboard.
And that will also give you an API key, an authorization token, and you also need to set a domain name when you do this. The domain name I'm using is flintest.ngrok.dev for the record.
And you can, to use this, you need to set a static domain. And with a free account, you can set a static domain and get access to all of this. So, yeah.
So I've just created a namespace that we're going to put the ngrok ingress controller in. I'm going to mark it with an annotation to tell Linkerd, hey, anytime a new pod shows up in this, go ahead and make it part of your mesh. And having done that, I can run Helm and install the ngrok ingress controller itself. Most of this is just Helm install, but when you run the Helm install, you do have to tell it, hey, here's my API key and here's my auth token. This is the second part of the demo that takes long enough that I always go, okay, is it really working? Despite the fact that I think it only takes 20 or 30 seconds. Yeah, kind of astonishing how impatient we get with things like this, right? Mm-hmm. All right, so that went. I'm going to make sure that it is indeed running. The astute reader will notice that I had -- wait on the Helm command, and then I did rollout status again, and that's just because I'm paranoid. All right. Given that we've got an ingress controller, we've got a service mesh, those are happily running in our cluster, it's time to install our application. So I will do exactly the same thing that I just did for the ngrok ingress controller. I'll create a namespace. I'll tell Linkerd everything in this namespace is fair game. And then I'm going to install faces. By default, we've got the face workload, which calls smiley and color. Smiley returns the grinning face. Color returns the color blue. We're going to tweak things a little bit here. We are also going to tell the GUI, hey, please take a look at ngrok auth username. That header should have, actually, I lied. It's actually ngrok auth user email. Sorry about that. When we go through and do authorization with ngrok, it's going to put in an email address in that header. And so we want to see that header to know who is authorized, to know who is logged in. We're going to enable smiley 2 and color 2. Smiley 2 will return a hard-eyed smiley. Color 2 returns green. I don't know why that says orange. We will use these later to show some of the things that we can do with the mesh and ngrok working together. And we're going to turn off most of the problems that Faces deliberately creates for you when you install it normally, because we kind of want to show off Linkerd and ngrok working together. We're not really here to go through and debug Faces. Faces was originally written as a demo to be able to go through and, the point of Faces was originally for it to go through and be able to show off a lot of problems and break things in a way that you could then go and fix. Dude, you can tell that we've been doing this live and changing things because this is not the right value. So everybody gets to see a little bit of under the hood madness happening here. Don't look at this too closely or something like that. One of the entertaining things about this one is that we are, in fact, doing all of this by actually having a program that executes the markdown, which is kind of cool.
Nope.
All right. So just pretend the last minute or so didn't happen. And we're looking at this helm command, which is going to set our auth header to ngrok auth user email and enable smiley 2 and color 2, turn off the errors, except that we're going to allow color to still fail 20% of the time. We'll wait for that to go ahead and be running. This is usually fast. There we go. And the next thing we need to do is we need to set up the ingress resource. So we're going to do this way. That's my host name. This is the file we end up with, where we have a secret that I'm going to scroll past kind of quickly that tells us how to talk to my auth0 instance, because we're going to use auth0 as shown here to do authorization. And then we've got this ingress that says things like, oh yeah, when you see Flynn test, then the slash path goes to the GUI, and off we go. So we'll create that. And if we are lucky, when I come over here,
folks in the audience can also go to flint-test.ngrok.dev to check this out.
And it will force you to log in. So if you log in, you can log in. I'm actually going to put this in the chat. You can log in as user A at test.com or as user B.test.com. Sorry, at test.com. Wow, the chat system does not really like the test.com part, the at test.com part. There we go. Oh no. There, finally. And this is the password in either case. You can tell we're very concerned about security for this demo. All right. So you'll notice we mostly are seeing grinning faces on blue backgrounds, but there are some grinning faces on gray backgrounds as well. Let me also show this other thing here, which is that if we look here, you can see that I'm logged in as user A on this browser. I want to show logging in as well. Except there we go. So if I go here, this one will force me to log in. User B at test.com. I'm going to copy and paste the password from another window because I find that typing it blind is very hard. And there you go. Now it says I'm logged in as user B at test.com. I'm going to stop here and point out a couple of things that may or may not be completely obvious from all of this. The first one is that this cluster is running on my Macintosh. It is not running off in the cloud somewhere. It's running on my Mac. Despite that, I just went to a globally available domain name, flintest.ngrok.dev, had to log in, and then it worked. Everything was great.
Yeah.
So one of the things that's a little bit tricky about this demo is that when you set it up and you run it, it kind of looks like you're just messing around with some random cloud cluster that you have running at GKE. But in fact, there's an awful lot of black magic happening behind the scenes because this is not a cloud cluster. This is a development cluster running on a Macintosh that's sitting in my house.
Yeah.
So kind of want to emphasize that pay attention to the black magic there. It's really cool.
Then I'm going to steal a screen share really quickly to show off some of the black magic and what's happening in the background. So as Flynn is playing around with and has his cluster up in the background, ngrok is automatically finding currently live, handling all of the requests to the application itself, right? Within that's coming from Flynn's machine, and we have folks, other folks as well joining right now, and you'll see that within ngrok, as this is happening live, we're getting this request from Flynn's machine, right? And we're also getting that ngrok auth username as people are logging in, and ngrok is working with OAuth to make sure that all of this is happening seamlessly in the background, right? Even though it's not hosted in the cloud,
Right.
Which is awesome.
Yeah, which is pretty cool.
Yeah.
All right. Let me get the... There we go. I just rebooted my Mac earlier this morning, and I already have too many windows open to quickly find the one that I want. All right. So Shub just showed looking at traffic from the perspective of the ingress controller using the ngrok dashboard. I am also going to look at this and show it from the perspective of Linkerd, where if I go ahead and do that, hey, for once I got the right window. So as I go through and look at this, first off, I get to see all of the namespaces in the cluster. If I dive down here into the faces namespace, I get to see a little graph of the workloads talking to each other. I can see that my color workload is indeed not working very well. It's failing about 20% of the time, which is what we told it to, so that's good. But I also get to see all of this stuff. And if I really want to, I can go and take a look at live calls here. And if I really want to, I can fire up tap and get to see exactly the same thing. But here's an interesting bit because, yeah, Shub just went through and showed off how we could see this sort of thing from ngrok. But this is a call from the face workload to the color workload. And ngrok doesn't see this call happening at all. However, Linkerd does. And so we can go through and look at it and again, see request headers and the response and all that good stuff. So this is a thing. Yeah.
Flynn, real quick, when you were saying about can you go back to the request itself? Where you're showing off the request there.
Yeah.
So are you showing right here, this is the request coming in from the outside world and the response within the service itself?
No, I'm showing, if we go back to the application diagram for a moment, I'm rapidly paging through slides on a window you can't see yet. All right. So here's our application diagram again, right?
Yeah.
The traffic manager gets to see things happening here. But this call is the one that's happening along this line from face down to color. So this is a call that is not possible for ngrok or any other ingress controller to see. Only the service mesh is going to be able to do this kind of observability for you.
Nice.
Yeah. It's this is not dissing on ingress controllers. This is just pointing out that ingress controllers and the service mesh have very different jobs, although those jobs end up overlapping at some points. They're very different jobs, and you actually really do need both to be able to cover the entire call graph of the application.
100%.
So with that said, in this particular case, we're going to go ahead and use the service mesh to fix the gray backgrounds. If we have, for example, the color 2 workload, which is running already, if we have color 2 and we think color 2 fixes whatever problem it is that color is demonstrating here, then we can go through and slowly ramp traffic over to color 2 using a service mesh. You can see that it is in fact already running, and we can also, everything we could see with the Viz dashboard GUI, we can see from the command line. In this case, we can see that color is taking almost 24 requests per second, and color 2 is currently taking no traffic whatsoever. That 0.3 requests per second there is actually traffic from the metrics subsystem itself. So let's go ahead. We are actually going to use a gateway API HTTP route to go and shift 10% of the traffic coming to color over to the color 2 workload, and then the other 90% will leave back at color. So if we apply this, as soon as we apply it, all 10% of those gray backgrounds should go away. And I also changed it so that color 2 returns green instead of blue to make it a little bit more obvious. So yeah, there we go. I'll leave it as an exercise for the reader. If we have 16 cells, then how many of them should be 10%? But the other thing that we can do is in real time, we can go and change that. So I can change it from a 90-10 split, or I can change it away from the 90-10 split. I can make it a 50-50 split just by editing the weights in that one route. And when I do that, we should start seeing more green. And one of the other kind of fun things is I can actually force one of the weights to 0 and get 100% of the traffic going over to color 2. As soon as I hit return here, all of the background should turn green and we shouldn't have any more gray backgrounds at all. Fun fact, the face workload is the one that's calling color. It is now talking to color 2. It thinks it's still talking to color. We didn't change anything in the application itself. One of the questions that we have here is about development teams and operations teams. We will come back with a kind of a more detailed answer to that, but I do want to point out, since that question came up, leaving things configured this way, where face is talking to color, and there's a broken color workload running that's having traffic routed around it, is operationally a very bad idea. Don't do that. It will be much, much better 3 or 4 weeks down the road after everybody has forgotten I did this, if you take the final step of replacing the color deployment with the fixed binary and then removing the route so that things are happening in a way that's straightforward in your cluster. Because I guarantee you, you will forget them after a week or so, and then people will get very, very confused as to why face is talking to color and color is taking no traffic. So yeah, so don't do that. Another thing that we can do, doing A/B testing of the stuff the web browser sees is pretty commonplace. And it's very easy to do that with an ingress controller. But we are now going to do an A/B test down deep in the call graph, which you cannot do with an ingress controller, but you can do with a mesh. And I'm depressed by how many times I didn't change ngrok auth user ID to ngrok auth user email. Oh well. So I have two browsers going. I showed you those where we've got one logged in as user A and one logged in as user B. But what we're going to do here is we're going to change the smileys depending on which user you're logged in as. So the browser that we've been using all along here, that I've primarily been showing you, like I said, there's my mouse. This is logged in as user A at test.com. And I also have another browser. You watched me log in with this one. This one is logged in as user B at test.com. So those two are different, and we get to distinguish between those two. On this display right now, as you're watching, the top one that says normal user is logged in as user A, and the bottom one that says test user is logged in as user B. Those are actually windows onto my two browsers that are running live. So those are the real browsers, I promise you. I'll show you that shortly. So both of these are running right now, showing us grinning smileys because we haven't started the A/B test at all. I'm going to use an HTTP route again that basically says take traffic to Smiley, and if ngrok auth user email is user B, send that traffic to Smiley 2. Otherwise, send it on to the normal Smiley. So as soon as I do this, then my bottom test user thing should start showing us hard-eyed smileys. And it does. It's so lovely when the demo gods come through for us, right? If you are trying this at home and you are also logged in as user B, you will also see hard-eyed smileys because, if you're logged in as user B, you're logged in as user B. We didn't do anything we're not looking at individual sessions or anything like that right now. Once we're happy that everybody really likes hard-eyed smileys, then, and this is another one where, operationally, this is not the way you want to do this one, but we can just go through and delete that match that talks about user B at all, and then the entire world will get sent over to Smiley 2, and everybody will see hard-eyed smileys. Like this. Ta-da! Now, I said, I actually said I was going to do this, and then I didn't do it. So let me do this. All right. So right now, there we go. Nope. Here we go. So I put back the one that's doing the A/B test where normal users, user A gets the grinning faces and user B gets the hard-eyed faces. And I wanted to show you. So there's my browser logged in as user A, and it is seeing grinning faces. And here is my browser logged in as user B, and it is seeing hard-eyed smileys. Just to prove that I wasn't lying to you when I said those were the real browser windows getting shown there. I'm just going to run through this again because that's easier than skipping things. So there you go. That's the demo of using ngrok together with Linkerd to both provide access and do some cool things. Shub, I think you had some stuff where you wanted to get into a couple of other use cases here. Or I think you had stuff where you had slides about another couple of use cases that we can talk about. And then I think we should go back and cover these questions in a little more detail.
Yeah, let's do it. I wanted to jump in really quickly. I know we had just, Flynn, that was great showing off how Linkerd can bind traffic and changes different. What were you saying?
I'm delighted that the demo gods smiled upon us.
Yeah, I think that was the first time where we did this live. We're at work the first time, which is awesome. What I wanted to get back into is
I'm going to interrupt there for a moment to point out that when Shub says this is the first time, what you should be hearing there is less, wow, you guys suck at doing demos, and more, there's a lot of complexity hiding behind the scenes here. So yeah, it's always really gratifying when things go so smoothly.
Yeah, we've done this a lot of times, so this is good. What I wanted to show off is Flynn did a great job of showing how Linkerd can redirect traffic between services depending on the email address of the user. On the ngrok side, ngrok makes it, again, we have a very easy, I'm going to steal back your.
Yeah, go for it.
ngrok makes it very easy to deploy the ingress controller, right? So this is how we get ingress into the application and the cluster. And we also make it very easy to apply rules to that traffic. Right now, what you're seeing is a sample module set that says add compression and add TLS termination to this. Now, additionally, on top of that, ngrok is also an API gateway, a full-fledged API gateway. So what that means is all of these requests that are coming through to ngrok, right? These requests that are coming into traffic, we're sending a response with the username from OAuth, from Auth0, and then sending that off to Linkerd into the services themselves. We can set actions with our policy module for our API gateway to make changes to that, right? So we can change expressions in a way we can add headers to them. We can compress those responses, rate limited directly at the ingress layer. So that's the request from the user directly to the application before it gets sent down to the cluster for Linkerd to handle rate limiting and all of that stuff down at the cluster layer itself. Additionally, you can also like rewrite the URL to say, hey, I've got 2 different services running. I want to send certain clusters to this different service. So if you did have a service that was just for heart faces, you can send those users there depending on directly from the ingress side before they get down to the cluster side. So I think pairing Linkerd and ngrok together, because we both have certain rate limiting as well as URL rewriting functionality here, really gives you a lot of what do I call it? It gives you a lot of
power.
A lot of power, definitely.
Yeah.
Definitely a lot of power, as well as like the ability to be flexible with how you handle traffic and what you do with that traffic that comes from your users. Do you have anything?
We fairly often get questions about, oh, well, should I do X at the ingress controller or should I do it down in the service mesh? And the answer is often, well, like in this case, if you want to do something before the traffic reaches the cluster at all, you don't have a choice. You have to do it with ngrok. If you want to do something deep down on the call graph, you have to do it with Linkerd. Mm-hmm. But beyond that, where they overlap at the kind of, at that entry point, often it comes down to a question of who do you want to worry about it? Yeah. If you want your application developers to worry about it, it often makes more sense to do that in the ingress layer because your application developers are more likely to be dealing with that stuff anyway. And if you want to make your platform engineers worry about it, you may want to have it done at the service mesh instead. But they do overlap a lot, and the ability to choose where you want a given thing to be managed is really nice.
Yeah, definitely. And I'm going to go back to our slides here to talk a little bit about these use cases you were pointing out, Flynn. So ngrok, what we just focus on right now, ngrok and Linkerd is focused on the Kubernetes layer, right? And we're talking about traffic coming from a user, an actual person who you want to see the traffic. We want to see this application that's showing off smiley faces or showing off heart faces, right? In another world, it might be I want one of my other applications or SaaS services to talk to an API or service that's hosted in a Kubernetes cluster. And it might be I want to be able to use the cluster I've got right now to talk to machine learning devices that are on the edge, right? We've seen a lot of our customers at ngrok who've deployed machine learning models directly at the edge, and they use Kubernetes there. And if you think about how where these edge devices are, there might be at gas stations, they might be at hospitals or facility or machinery facilities where they're building cars and whatnot. You need these edge devices to be very secure. You need them to be resilient. You need them to be able to be scalable and like make decisions in real time. So those 4 pieces are very important. And like, that's where our partnership comes in, right? Like using ngrok as a way to get ingress into those applications is great, right? You have the ability to handle all of the traffic coming to those edge devices in a very high availability, automated configuration, encrypted way. And then when you get down to the service layer itself within the clusters, you need a way to make sure that when they're talking to each other, that's scalable, right? You make sure that
Yep.
that's secure, it's efficient and reliable, so that when you get lots of traffic, or if something goes down, an edge device goes down at a hospital, that it's able to move on to something else very, very efficiently, different service very efficiently. So yeah, this was cool. This worked, and this was great.
Yeah, next time I'll have to do one of the ones where we drag in the Raspberry Pi cluster and things like that, just because that would be entertaining too.
100%.
Yeah.
Yeah.
So let's tackle some of these questions over here. How is Linkerd different from Istio? I'll take that one first. Obviously, Linkerd is better. Less facetiously. Istio is probably the most completely featured service mesh out there. Istio really tries kind of to make the full power of the Envoy proxies it's built on available to you as a user. The price for that is operational complexity. Envoy is extremely complex. Istio can also be extremely complex depending on what you want to do. There are things that Istio can do that Linkerd cannot do. On the other hand, Linkerd is the one that's being designed to be operationally simple. That's a very strong focus of ours. You can get a lot of value running Linkerd even as a 4-person startup without having anybody whose full-time job is the care and feeding of Linkerd. I don't actually know of anybody whose full-time job is the care and feeding of Linkerd. Like anywhere, even the people at Buoyant who work on Linkerd full-time, we don't have anybody whose full-time job is babysitting our production Linkerd installs. So that's the biggest difference. Is Linkerd is faster and more lightweight, but the biggest difference has to do with operational simplicity. I'm going to let Shub answer the question about how ngrok differs from Nginx.
Yeah, we get that question a lot, right? When you think
Oh,
of
yeah.
controller, you think of Nginx in a lot of cases. I think the thing that really stands out here is when Flynn was going through the demo, he didn't have to spend additional time setting up other resources. We were online as soon as we applied ngrok. Now,
well, admittedly, we had to install the ingress resource, but we only had to do one of them.
we had to do exactly.
So yeah,
It was very simple to do. We didn't have to go and set up a load balancer, figure out how to our NAT directs traffic to it. And also additionally with ngrok, we just talked about that. We touched on it a little bit here, but ngrok works anywhere in the same fashion. If you're connecting to not just your Kubernetes ingress controller, but if you're connecting that in your Kubernetes services to APIs and other applications running anywhere else, you can also continue using ngrok in that one same place and get that managed service, right? So we were able to show off that ngrok dashboard where you're able to see traffic in real time, and you were able to make changes to the headers and how that traffic was coming through. That works across the board, not just in Kubernetes, anywhere your application or is running. So imagine that instead of having to manage a different piece of software for everything that you do in your organization, you've got one layer that is the door, and that's ngrok. So you don't have to buy 3 different doors and have to find a different handle that for each one of them, right? That's a little convoluted metaphor there, but okay.
I was going to say one of the coolest and biggest differences that I see there is actually, in a lot of ways, simpler than that even. You can't fire up a K3D cluster on your Macintosh and put Nginx in front of it and then have people who aren't sitting in front of your Macintosh talk to it.
Yeah.
You could enable that to happen by firing up Nginx on your Macintosh, going to your Bastion router in your house and opening a hole through its firewall to port forward back to your Macintosh, and then figuring out the IP address that your house has externally, which is probably horrible dynamic NATed crap anyway, and then probably also having to work with the Mac firewall. It would have taken a little bit longer than typing kubectl apply and hitting return.
Yep.
Just saying, so that's a pretty substantial difference between ngrok and a lot of the other ones. If you are using a cloud cluster, then some of that changes, but I can fire up a K3D cluster and tell it to install ngrok a lot faster than I can fire up a new GKE cluster as well. That, this is a common complaint of mine with the cloud clusters.
Even with GKE, you still have to think about how public IPs routing happens on the ingress layer.
Yeah, you have to. There's a fairly entertaining dance that happens a lot of the time, and OAuth actually makes that a lot worse, because a lot of the things with authentication end up caring about your TLS certificates and SANs and domain names and all that kind of stuff, not just the IP address.
Oh, we didn't even talk about how simple it was for you to use Auth0.
Yeah, actually, that's a good. That is a really good point. Auth0 was behind all of this, which we pretty much did just by tweaking a couple of things in the ngrok dashboard.
Yeah.
And the other one that we should have mentioned but didn't is that y'all should have noticed that I was using HTTPS URLs, and at no point did I have to go through and figure out how to get a cert from somebody to make that happen.
Yeah, we take care of all that.
Yeah, so next time we should emphasize some of that more. Oh no, wait, we've got another question coming in. I guess we have to hurry. ngrok and Linkerd addressing common challenges faced by developers and ops teams. That's a fairly challenging question to answer really quickly. I think the way I would answer it is that earlier I was talking about how you could do things like choosing the role that you wanted to be able to manage different things where they overlap. That, I think, is a part of it. But another part of it is that from Linkerd's point of view, and Shub will keep me honest, but I think from ngrok's point of view as well, in a lot of ways, what we're trying to do is provide tools that either your developers or your operators can use to solve whatever problems they run across. We can talk about best practices. We can talk about some typical use cases that we see people solve, but a lot of it boils down to things like, well, you now have the tools to do progressive deployment anywhere in the service or anywhere in the call graph. You now have the tools to go and, I don't know, rewrite URLs on the way in if you figure out that one of your developers has done something horribly wrong and it's 8 p.m. on a Friday night and you don't want to pay people overtime, so you just want to switch it back to the one that works quickly.
We also have
big deal. Yeah.
We don't have to worry about going to a security team and opening a Jira ticket to set up SSL and TLS termination. We don't have to go to a different team to set up OAuth. We don't have to go to a different team to redirect traffic or do rate limiting.
Yeah. The self-service model, ultimately when you get down to it, self-service is necessary for developing at scale. The only way we as an industry have really figured out to develop it at massive scale, you've got 1,000 developers or whatever, is the microservices model, where you are working, releasing, deploying, testing, all of that is in parallel. And that does not work if you're constantly opening ops tickets to get things deployed.
Yeah.
So the self-service aspect of all of this is a big deal.
I know we had someone joining us from Egypt, and one fun thing about that is ngrok handled load balancing for that person when they logged onto your link. So they were routed through our Europe point of presence.
Now,
to deal with that.
Admittedly, they still had to come through and end up talking to my Mac in North America, but that's kind of a different issue, right? Yeah. If we were doing this in a properly distributed way rather than one developer's Macintosh, then we'd have a lot more tools there. Really quickly then, operational costs for the service operational costs for the service on providers. I'm going to interpret that as operational costs in general for the people who are trying to run the applications. I am a terrible person to talk to about the costs of using ngrok in production. Fortunately, there's somebody else here who's better at that. Linkerd, I can tell you, does a pretty good job of reducing operational costs. One of the things we just did recently even is a thing called Hazel, which is the high availability zone aware load balancer. So if you have a cluster that spans multiple zones, like multiple availability zones, a workload in one availability zone talking to a workload that has presences in its zone and also others will stick to its zone where it can, but if something goes wrong or it gets too much traffic, it will automatically go out to other zones to help manage the load. And so you can literally deploy Linkerd, turn on Hazel, and suddenly your cross-zone traffic falls to 0 without you doing anything else, which is a great way to manage cost in some cases. The other one, another cost that people often don't consider because it's not technically an operational cost, but you remember I said that we don't know of anybody who has a full-time Linkerd person on staff, for the care and feeding of Linkerd. So that's engineering you don't have to hire if you are running Linkerd. And if you are using ngrok, you probably don't have to hire somebody whose job is the care and feeding of your ingress layer either.
Exactly. And again, we reduce the amount of time it takes to get online, right? That speed is very, and you don't have to spend time going from one person to another to just fix a simple thing like I need TLS termination upgraded to v1.3. All right.
Yeah.
We definitely reduce costs there, and then you're not setting up a lot more resources on your cloud providers. So you're saving costs there. ngrok is a full-fledged API gateway and device gateway, so you don't have to go get multiple tools to handle the same issue. For ingress, you can do it with one tool. So in terms of costs, definitely, where Linkerd and ngrok together definitely reduces a lot of costs. Cool.
All right, team. Well, I got to step in here and let you guys know we are at the top of the hour. But Shub, if you do have any closing thoughts, we do have some time for that, of course.
No, thank you for being here. Thank you for coming to our talk. I know Flynn and I had a great time demoing this and talking ngrok and Linkerd. You can go and sign up and do everything we did today for free at ngrok.com. And then, is it linkerd.com, Flynn?
It's, I think that's one of the handouts, the Bell overview, the Buoyant Enterprise for Linkerd overview. But start at buoyant.io if you don't want to think too hard. Linkerd.io will take you to the full-fledged open source or nothing Linkerd. I am happy to talk to anybody on Slack about the difference between the two, but the short version is, no, really, we won't sell anything, and Bell is free for anybody out of production and for a lot of situations in production. So, yeah.
Awesome. Thank you, folks.
Yep. Happy to catch up with anybody on Slack if you have further questions. I really do find myself thinking that Linkerd is the simplest way to get service meshes working. And the more you work with a service mesh, the more you will find yourself wondering how in the world you got along without one. So yeah, highly recommended.
Very good. Well, Flynn and Shub, thank you both so much for joining us here on Techstrong Learning.
Thanks for having me.
I know we went over a couple minutes, but I feel like we got some of the most vital information over those last 3 minutes as well. So I really appreciate our audience sticking around just a couple minutes longer as well.
Likewise, thanks.
Of course. So before I officially release everyone, stick around for just one more minute. I'd like to remind you that we did record this session today, and we will be sending it to you via email here shortly, but you can also find it living on the DevOps website. That's devops.com/webinars. One quick call out for our survey that's pinned to the top of the chat, but you'll also find it in the handout section on the left side of your screen. You'll also find a lot of other handouts there, so feel free to grab those before we close things out today. But that survey is really integral for us. We look at those results as we fine tune our programs for the future. So please do let us know what you thought about this session today, and we'd love to hear from you. Additionally, I would like to thank ngrok for sponsoring this program, and to everyone here, thank you so much for joining. We really appreciate you spending time here with us, and we hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect. Thanks again, guys.
Thanks much.